Okay, today we are gonna talk about the ANOVA test. That's one-way ANOVA. In particular, I'm talking about lecture 33, ANOVA part 1, and you will find this in Appendix B in your book. So let's see an example. This is in your slide number 22, where a researcher wanted to determine the effectiveness of various treatments on glucose level of diabetic rats. And there are four groups of rats. Each sample is randomly distributed, randomly assigned to like one of these four treatments. Either they're in the control group or they receive fenugreek. Another group received garlic, another group received onions. And then, after 15 days of treatment, the blood glucose was measured in milligrams per deciliter, and these are the blood glucose. Now, we want to test if they all have equal means, or at least one of the means is different. For this analysis, let's set alpha level of significance equals 0.05. So once we check these conditions, and I have already talked about how can you use QQ-plot to check if if the populations are normally distributed in another video. Now, step one is to set our null hypothesis. Null hypothesis is that all means are equal, and the alternative hypothesis is at least one population mean is different from the others. We have already selected the level of significance equals 0.05. That is, out of 100 samples, we want to be like 95% confidence out of 100 samples. That means in the 95 samples, we are expecting this same conclusion that we're going to have this time. So for this ANOVA test, we're going to use Excel, and I have the data set entered right here. Let's blow this up a little. And notice that the formula wants us to calculate the MST and MSE. So for MST, we have to check the difference between sample means and the overall mean. So let's calculate the sample means for each of these samples. So I'm gonna write X bar here, X bar 1, X bar 2, X bar 3, X bar 4. So I'm just gonna get the average of these values. And when I drag this, I'm gonna get the average of all these numbers here, 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 and here. And then I'm gonna need the count, that is N1, N2, N3, N4. And for that, I just count the number of observations. So there are 8 observations in each of these samples. And while we're here, let's also calculate the degrees of freedom. Since we are going to use the X bar, we lose 1 degree of freedom. So our degrees of freedom is essentially 8 minus 1 for each of these samples. Now, we need to calculate X1 bar, X bar 1 minus the overall average, X bar 2 minus the overall average, and so on and so forth. So we need to calculate the overall average as well. For calculating the overall average, we can get the average of these averages. Then You can also get the total count, that is how many observations we have in total. That's the sum of all these counts here, right? And the sum of total degrees of freedom is this. Or in a way, you can think of like this: 32 minus 4 is 28. That is n minus k, and k is our number of sample: 1, 2, 3, 4. So 32 minus 4 is 28. On the other hand, we also have n1 minus 1, n2 minus 1, n3 minus 1, n4 minus 1, and the sum of all the separate degrees of freedom is 28. Okay, now we can calculate x minus x bar for the respective samples. And our x is actually it's x bar minus the overall x bar. So this minus this mean. So this minus this. Now, when I can drag this to this point, notice that the Excel will move the formula as well. So to stop that from happening, we need to fix these cells here. Let me increase this a little. So for here, we have this minus this, but for here, we have this minus this. There is no value here. So to keep the checked, we can add $sign in front of the cell, in front of the column and the row 11, so that this doesn't move, but this moves. Okay. Now we drag it up to this point, and now everywhere the cell, red cell, is not moving. Only the blue selection is moving. Okay. So we have x bar minus the overall x bar, which is in our formula, which is here. And then we can get the square of these terms. So x bar minus the overall x bar to the power 2. That's this number to the power 2. Then we drag this to the last end, and then we take n1 times x bar 1 minus x bar to the power 2. So we have to multiply n1 with this number. This is n1, this is n2, this is n3. So multiply this times this. Then we get 4 numbers. And then now we have to add all these numbers to get the sum square total, or SST. It's sum square treatment, or SST. Then you can easily get that sum this. And we know the degrees of freedom here. How many samples do we have? We have 4 samples. So k equals 4 minus 1, because we are using one overall mean here. For all this, we're using one mean here because we subtracted that mean. So 4 minus 1 equals 3 for the numerator degrees of freedom. Degrees of freedom numerator is 3. That is k minus 1. So the MST, or mean square treated, is the average. So total divided by the count. And we have MST equals this. Now let's calculate the, now that means we are done with this part, MST. Now we have to calculate the denominator. The denominator is MSE, and the numerator is MST, denominator is MST. Together their ratio builds F statistic. So let's see how to calculate MSE. MSE is the N1 minus 1, N2 minus 2 minus 1, and all of these we already have here. N1 minus 1, N2 minus 1, N3 minus 1, and 4 minus 1. Okay. Times the S1 square. This S1 is the standard deviation of sample 1. And when I put square, that's the variance of sample 1. S2 square is the variance of sample 2. So let's do that. We have variances. We can easily calculate variance. Now variance.p is population variance formula. Variance.s is going to give you the sample variance formula in Excel. So variance S, select these numbers. We're calculating sample variances. Hold on. Variance dot sorry, it's not variance, it's just var. Var S gives you the variance of sample. So you have to close the parenthesis, so we get the variance, sample variance right here. Drag it to the end, you get the sample variances for all these samples. Now for the other part, variance times N1 minus 1, we already have N1 minus 1 here. So multiply this with that, we put it here, multiply N1 times the variance, and so on and so forth. Now we can add these numbers to get the SSE, that is the sum square error. So this is our SSE, where we sum all these numbers and get this. Okay, and the degrees of freedom for this is what we are using 4 samples and 4 variances, right? So each time we are using the mean, we lose 1 degrees of freedom. So degrees of freedom in the denominator is 28. Okay, now what is the ratio? What is the average mean square error? The average is when you divide total by the count. You get MSE equals 286.843. So now we can go ahead and calculate the F. This is calculated F, or you can call it F naught, F0, something like that, as it says in your PowerPoint sheet. And then now we have these two numbers ready. We can just calculate the ratio. Calculated F is MST over MSE. Okay, so it's 58.2091. Now what is our critical F? Notice that what we're trying to do here is this. So our F stat, the calculated F is somewhere here, is way down the line to the right. And notice that is only in the right axis. That's the characteristics of F statistic. And we are testing if it's beyond this critical value. If it's beyond this critical, if our calculated F is beyond the critical F or not. And we know that alpha equals 0.05. So that number is known. So now let's try doing that. So the critical F critical, we can get it in Excel equals F. This time we have the probability 0.05, the area, the blue area is 0.05. We want to find the score, the critical F, which is on the x-axis. So I'm typing inverse, F inverse, because we have the probability, we want to go back to the score. If we have the score, we want the probability, then we could have used f.dist, dist, distribution. So we know the probability as that's 0.05, and the degrees of freedom. Actually, it's since it's right-tailed, so we probably have to specify that too. So finv.rt, rt is the right-tailed. It says here returns the inverse of the right-tailed if probability distribution. So probability is 0.05. Now the numerator degrees of freedom comes first, and the numerator degrees of freedom here is 3. So let's type 3. And the denominator degrees of freedom comes second, 28. Parenthesis close, press enter. We have 2.494669. That's our critical F. Now the calculated F is beyond critical F. That means our F statistic, the calculated F is somewhere way ahead of this point, and this point is 2.94. And that means we reject the null hypothesis that all means are equal. That means at least one mean in here in the sample, and one population mean is different. So we reject the null, and that means it provides evidence in favor of the alternative hypothesis. On the other hand, if we ask ourselves, what is the p-value? What is the p-value? That means what was the smallest level of significance where the null hypothesis can be rejected. Now we know the F score, that is the value on this x-axis, which is 58.209, where we are trying to calculate the probability, that means the area of this blue shaded region. Can we do that? We can. So F, let me see if FDIST RT, and we know the value, which is 58.2091 is our calculated, and the first degrees of freedom was 3, second was the denominator degrees of freedom was 8, and then this is very, very small. This is very, very small. It's a scientific number, so p-value is almost 0. And when the p-value is almost 0, then it's also the evidence in favor of rejecting the null. Sorry. Now we have another method of attaining at the same conclusion, which is using this table. We can check the degrees of freedom in the denominator, degrees of freedom in the numerator. We have degrees of freedom in the numerator should be one value 3, and the degrees of freedom in the denominator should be another value 28, and you can find the value just like you did for T scores or Z score from your book. But that's old school. We're not going to use that. So now we conclude that we can reject the null hypothesis in this study. But there's another way. There's another way to easily or more effortlessly calculate the same. Using Excel, you can do that. So we go to Insert menu and do the data analysis. Let's see if it's in the data menu. Okay, let's go to data menu and do this. Click on here, data analysis, and the first one, ANOVA single factor, you select this. And it asks you to select the input range. You can select this input range and also check on this labels in the first row. Labels in the first row. And then I selected new worksheet. So the result will generate in the new worksheet. Okay, press OK. And it creates the ANOVA table for you. Notice that it also reports the p-value, which is very close to 0. Like we found before, p-value is exactly same what we had before, and the sum squares and mean square between groups and within groups. Between groups is the MST, and within group is MSE. F is 58. The calculated F is 58.209, which is the same that we received, 58.209. So this makes your life easy, but now you know the ins and outs of one-way ANOVA table. Thank you.